let's take a brief moment to relax and focus on our breathing and briefly meditate. So sit up tall, gently close your eyes, rest your hands on your thighs. They can be either palms facing down, or you can have the palms facing up, and you can even make an okay gesture with your forefinger lightly touching your thumb. Take a deep inhale through your nose, feeling your lungs filling and your abdomen filling. And slowly exhale also through your nose. On the next inhale through your nose, feel your spine growing taller. And as it lengthens, relax your shoulders. And slowly exhale through your nose, feeling the stability of that long aligned spine. On the next deep inhale, send the breath to any parts of your body that may be feeling somewhat tense. And as you slowly exhale through your nose, feel that tension release. Let's take one last deep inhale. Feel that good air entering. And exhale through your nose as slowly as you can. Feel a sense of calm and relaxation. And gently open your eyes. This multiple choice math problem comes from the College Board. It's from section 4 of the SAT test, which does allow calculators. And the problem says, a rectangle was altered by increasing its length by 10% and decreasing its width by p%. If these alterations decrease the area of the rectangle by 12%, what's the value of p? So give this problem a try, see what you can do. It's okay if you're not sure how to approach it. You can even just take a guess. And in about a minute, we'll have a look at it together. Let's take a look at this. So there are a couple of ways that we can approach this. You might have thought, well, let's go ahead and start this algebraically by letting variables of L stand for length, W for width, A for area, P for percent. And you could go down that path, but what I realized was that was going to be pretty complicated. So I actually want to show you an approach here that involves going rogue. And what that means is actually picking values. We're talking about a rectangle that's being altered. So I see that there's information in here about percent. So I'm just going to draw a rectangle, and I'm going to pick an area of 100 because 100 is great to work with for percent problems. And I could pick a rectangle of 10 by 10, but that's a square. I wanted to pick a rectangle where the length was going to be different from the width. So I went by a 5 by 20. So this is not drawn to scale, but let's imagine that we had a rectangle that was 5 units by 20 units. And again, I don't know that this is the rectangle they're talking about, but I said to myself, what would happen if we just drew a picture? So we have length, width, and area. The length is 20 units, the width is 5 units, and the area is 100. All right, so far so good. So now let's talk about the second rectangle. So it's going to be altered. The length is going to be increased by 10%. So what that means is 10% of 20 is 2, so it's going to become 22, right? So its length is 22. That's the new rectangle. And they're saying that the area of this new rectangle is going to be decreased by 12%. Okay, so if it's decreased by 12%, and this is why I picked 100, right? Decreasing that by 12% means 100 minus 12, which is 88. 100 minus 12 is 88. All right, so I now know that the width has to be 4, because length times width gives me area. So all I have to do now is look at what the question is asking, which is, what is P? And P is the percent that the width has been decreased. So if the width went from 5 to 4, that means it became 1 unit less. And 1 unit of the original 5 is 1/5, which is 20%, right? So 20% less of 5 gives me 4. And what do you know? 20% is answer C, which is the correct answer. Now you may have thought, well, maybe you just got lucky and 5 and 20 just happened to work. It turns out that if you pick a rectangle of 100 square units, you could do this for a 10 by 10, or you could do it by 50 by 2 unit rectangle. And this method will show you the same result, which is that the width will be reduced by 20%. So this strategy involves not necessarily doing the first instinct solution, which is algebraic and pretty convoluted, but drawing a picture, setting some actual values of what the rectangle may be, and seeing what might happen. And lo and behold, in this case, we see that setting some actual values, picking some actual values for the dimensions of the rectangle, allowed us to see what the relationship was. I hope you enjoyed seeing this strategy. If you have any questions or any suggestions or requests, please feel free to leave them in the comments below. I always love hearing your thoughts. If you subscribe to this channel, you'll be notified of new videos as they become posted. I enjoyed working together, and I look forward to seeing you next time.